What we want to talk about is a little bit about car security, so about something PKI's cars and what's so special about the topic. And because we are on OpenSSL Conference, we would like to talk about our experience writing our own OpenSSL provider. And finally, we would like to share what we learned from that. So, who are we? I am Dragan, PKI architect, and this is, maybe you choose yourself.
My name is Peter, and I worked together with Dragan and the team on this automotive PKI for our cars.
Thank you. So we are working for Mercedes-Benz Tech Innovation Company. We are 100% subsidiary of the Mercedes-Benz Group. That means we don't build cars, we do the technology. In my opinion, this is the more fun stuff, for me at least. Our company does something like SDV, software-defined vehicles, an Eclipse project. We are writing Mercedes-Benz operating system parts, a part of the Mercedes-Benz operating system. We also have a big security group. We do offensive and defensive security, and in-car, out-of-car security architecture. So, which brings me to why we do cryptography around cars. So, two topics. We invest, Mercedes-Benz invests a lot of money and effort into security. So what I didn't know when I started, there is a lot of regulations around cars. For example, EU and EC around R155 is a regulation around cybersecurity management. That means there are federal agencies checking our security architecture. So we do invest in security by law. And the other thing is, I'm really afraid about one topic that is not decrypt now, harvest later. No, harvest now, decrypt later, the other way around. Is what happens to a fleet. Just remember what would happen when all the trucks in your company are remotely exploitable and stop working. So as an example, take the Black Hat 2020 hack, where a group of security researchers invested more than 1 year finding exploits in our cars. And yeah, they invested really a lot of money and resources, which I think it's a big value to hack our cars. So the bigger the value, the bigger the invest. And therefore, we do a lot of stuff around security. And I think
then we
will tell you more about that.
Thank you, Dragan. Mercedes-Benz operate his own PKI to ensure the security of our cars. Now I will explain for what we do it. We want on one hand side that only Mercedes-Benz and the authorized suppliers have, we are sure that we have the integrity of our ECUs, electronic control units, from us and from our authorized suppliers. The second point is that we can manage the access to our to these ECUs for diagnostic and coding processes. The third point is we want to trust other companies that they can give us information and apps to enhance the driving experience on our cars. That's the fantastic things that you see if you drive with our cars in the head unit. And the last point, we have communication between the cars and the backends. And clear, for this one, we need also TLS. Now we come to a special thing. We use in the most cases a special algorithm, this ID25519PH. Why we do this? The decision for an algorithm which we want to use in our car lines was very early in the build process. We start in the year 2015 for a new car line in the year 2019 to decide which algorithms we will use. And then we make contracts with our suppliers that they also implement this algorithm in the ECUs. Why we decide explicitly this PH algorithms? The reason was that we have not so many space on disk and memory on these ECUs. That was very small processors, and that is the problem that we decide that we will use this ID25519PH. The next topic was we decide that we use our own OID. You will see that's not the best decision. And ID25519PH did not go beyond the draft status during the standardization yet. And in the year 2017, at the 5th May, the PH algorithm is deprecated and will not standardized. But we have created the trust anchor. What should we do? It was too complex to change it, and that's the reason why we use it until today. And the next problem is, a car, you know it, have a really long service time. That means we must support the ECUs and the cars for more than 20 years, and we cannot easily change something in the cars, also not the keys. So now we come why we will use OpenSSL. That's simple. It's on one hand side for our suppliers easier to can develop and test their ECUs. In other cases, as we do it before we want to use OpenSSL, we say them, look that you program, handle this crypto things on yourself. And that's complicated. Also for our Mercedes-Benz people, they will test the certificates, and also they will check the chain. And it would be really easy, we can use OpenSSL. And for ourselves, as developer and the tester team, that we can validate the implementation and also can validate our certificates. That was what we think. Then, I and Dragan think, what will we do? We have not a full support for ID25519PH. We can not make a signature with this algorithm to signature our X509 certificates. We cannot handle our own OID, as said before, and we cannot work with attribute certificates. But our business unit has the requirement that we will use attribute certificate to give the people more rights. And on the finalized side, we want to bring these attribute certificates and the holder certificates to a PKCS 12 container. That was our requirement to OpenSSL.
Yeah, thank you very much. And so let's start the journey. Our first try was, okay, it's easy. There's just the context, you have to process it, and that's simple, I think. So I started by just copying the current code and adding PH functions, and it did not work. So you see on the right side, left, right side, this error, and it haunted me a week. It didn't understand what it means because I never did anything before with OpenSSL. This is the first time I tried it, and it was really pretty fast, clear after a week. We needed external support. Side note, it's something with the key management that should have been registered. So we had then a developer, and we hired a developer around 2 years ago, no, 1 year ago, I don't know, it doesn't matter. And we decided to implement all these functions as a provider, because OpenSSL 3.2 had suddenly PH support, but not in X5 or 9 and other stuff. It is only in the crypto was all the PH variants of several algorithms sadly there. And we thought writing a provider would be faster. So what is a provider, you might think? I wasn't aware of that. My first main model in my head was, this is something like Linux file system switch, a plugin system, a bunch of function pointers with types. Oh, great, it would be easy to do it. Yeah, so OpenSSL is a little bit different. It is an array, so an OpenSSL provider is an array of mappings from numbers to function pointers. And I personally think the reason behind it is to be completely independent from anything else. So you can run a FIPS binary, your old FIPS binary, in any OpenSSL versions later. So I think this is the main reason why, for me, maybe you can correct me, why this design decision has to be done this way, if I knew that earlier. But anyway, this is a small overview what you need to implement in an OpenSSL provider. It's divided in operations, and if you're doing simple stuff, you only need to implement one operation. The complex stuff, you need more. I need to skip this. Okay, first real step. What we want to do is to create a file with our own OID on disk. So we implemented the fetch function, key init, key generate, and an encoder. And OpenSSL calls us firstly with, hey, give me the functions. And we respond with an array of number and functions. And what we do in keygen init and keygen generate is to call evp keygen g. We upcall it to have then the private and public key in the library context. And all we need to do is to put our own OID with the help of ASN1 help us from OpenSSL. And it worked. We had then a private key on disk. And the next step, it does not fit on, so where can I start it? So I wanted to create a sequence diagram, but it would not fit. So this table is just the functions that we implemented, and the other side is what the functions do on upcall or comment. So I would point out two specific stuff. First, the decoder decode. What it does is it reads and parses the key file It extracts the private key and generates a public key. And then by a callback, we load then that key to be later be processed in the OSL functions digest sign, EVP digest sign functions that we also upcall with an EVP key that we generate with the extracted private public keys, with the difference that we use another other parameters, namely selecting the default provider to get the default provider selected and selecting the pH algorithm. And afterwards, it worked. It was correct, but it took a lot of time. The last step, I mean, we can now we can sign arbitrary files, but what we want to really do is create CAs and, certificates. The rest was not that much work. We only needed to implement the encode in the DAR variant, also doing some ASN helpers to get the OID there. And what we stumbled across was we forgot to register our own OID to OSL Core. It took us several weeks until we got behind, oh, okay, there is an OID missing, we need to register it. And after that, we were able to create finally a CA with our own extensions with OIDs, and that's it. Here's a short overview of what we did need to implement to get to the point. You can count it as a lot, in my opinion. And the other question is, can you use it? If you're a supplier, yes, because the license is special, and it is open for partners in shared projects. So everyone can see and use it in the projects if the partner is involved in a shared project. I wanted to mention this in this round because this is an example how different kind of sharing can happen, and maybe this is new to me. It was to me, so maybe it's also new to you. By the way, I also included a press release regarding Mercedes-Benz involvement into the inner source project. And Mercedes-Benz is heavily supporting them, or support this kind of license model. Okay, conclusion. We invested a lot, time, effort, to only reach the minimum. We are not the big team consisting of C developers. We do a lot of other stuff. So my key takeaway is you need a full developer when you want to extend OpenSSL. I knew that before, but I didn't believe it. Now I believe it because I experienced it. And because most of the time we were reading documents and OpenSSL code and going to GDB and figuring out what is OpenSSL doing here. And that's, I think, the key takeaway for everyone, for you. So hopefully you enjoyed this talk. Thank you for listening. And
thank you.
I'm sorry, did I correctly hear that you use the EVP PK API as up calls from the provider? or it's my misunderstanding?
Which one? The P key upcall? Yes, we do it in the initializing process, yeah. Yeah, maybe there's a better way. You're right, but
why?
This is...
Well, from my perspective, it puts the things a bit upside down.
Yeah, I understand it. I understand completely what you're meaning. It felt not like programming like this way. It felt like programming this way.
Yes.
But this is the story of how we get there, and we.
Okay, thank you. Well, I have two more questions, if you don't mind.
Yeah, sure.
Were there any obstacles to ask about your problems at GitHub? I can't recall from the top of my head any requests for public GitHub, or you could also use the commercial channels, I think, because it's would greatly simplify things for you. The first question. And the second and the last, how many custom patches do you have? Definitely not limited to prehash variant. And do you have some plans to contribute, for example, PKSS 12 support of attribute certificates and something like that?
Okay.
Thank you very much.
First, to your first question, we hired a developer and he worked with his own address. So you didn't see my email address, so you saw his email address. But he was involved and talked with several of the OpenSSL community. So the second question was patching.
Yes, if you make so massive, if you made so massive development, I'm pretty sure that you have a lot of custom patches to OpenSSL, right?
No.
No. You were limited only by PKI stuff.
Yes, thank you.
Okay.
This is what our main goal was. We didn't want to. Wait for pull requests being there. We wanted everything inside the OSSL provider, so that anyone who wants to use it in the projects just uses our code, and then no dependency to OpenSSL core, and it's working.
I see.
In theory.
But at one of the slides, you mentioned, for example, attribute certificates.
Attribute certificates, okay. The attribute certificate we did not implement. I said the minimum, we did the minimum. So we created X509, and I wish we was there with attribute certificates. I saw that in 3.4 there is an...
Yeah, 3.4, but still not in PKSS 12, I think.
Yeah.
Okay, thank you very much.
You're welcome.
I'm a beginner with programming providers myself, so I can have some sympathy for your difficulties. Is there anything that you would like from OpenSSL side to help? Would have been helpful, maybe concerning documentation or things?
I don't criticize anything.
But is there anything that you couldn't think that could have been helpful?
I think something like working with the X509 stuff, anything around ASN1 structures, changing it would be easier for us. So all this fuss, ASN1 decoding, encoding, we only wanted to change an OID, and we needed to do a lot of stuff to get to that point, right? And we try to be as compatible as possible, and therefore we did upcall a lot and extract our secret keys and put it in the library context and get back and reuse it, only to be compatible. So this is my assumption that I was talking with my developer.
Okay, and one last question over there.
Yeah, I'll make it quick. In hindsight, Was it worth the effort to implement this provider instead of maybe just using RSA or ED25519 without the pre-hash variant?
The issue is known to RE development, and they won't do it again. But this stays. So when you see the V model, not the V model, the Mercedes-Benz V model, the V development model, a car stays decades, and therefore we need to support this for decades. So it won't go. So the effort was okay, because the PH algorithm stays for a long time, for a very long time. Yes.